Okay, this is for Chloe and whoever else is watching. This is day 1 of 3 for geometry semester review, final packet. We are doing 3 days of review and we're starting on Monday because Wednesday a bunch of people will be out for track. So I'm kind of knocking Wednesday out, so at least we'll have Monday, Tuesday, Thursday, and then semester test will be Friday, Monday. First and fifth period will test on Monday. So, yeah, so you guys will have that. We're going to go front to back. There are 50 questions on this review packet. Your test will have all 50 questions, but you only have to do 45 of them, and you get to use this packet on it. So write down any information that you want. You know the drill. All right, chapter 6. Oh, round decimals to the nearest tenth. That's just one decimal place for everything, unless I specify otherwise. All right, so chapter 6 was all about, like, bisectors and altitudes and blah, 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 all that good stuff. Okay, so they're saying this guy is a centroid. Okay, so E is a centroid. And here was the deal with centroid. When it's a centroid, the smaller piece is half the length of what the longer piece is. Okay, like if this is 1, then this is 2, right? Don't write this down. Here's a small piece, here's a big piece. So if this is 2, then this is 4, right? Here's a small piece, here's a big piece. If this is 3, then this is 6, right? It's half the distance. The smaller piece is half of what the longer piece is, and that's how a centroid works, okay? So it says BD here. From B to D is 12. Oh, the full thing is 12. They want us to find ED, which is the small guy.
8 and 4.
Question mark. Yes. So, yep, we're looking to see, like, 2 pieces. This one has to be, the smaller one has to be half of the other one, but they have to add up to be 12. And you're right, it has to be 4 and 8. And so ED is 4. And that is all. Yeah, not too bad. Okay, do we need to write anything down about centroid? Maybe I'll do this. I'll say X and 2X. Centroid. I don't know. Does that help at all? Whatever. When you have your small pieces and your big pieces double what your small pieces. Whatever. If you don't want to write that down, you don't have to. Okay. Next, PO, which is this guy right here. He is an angle bisector of MON. MON. What's it mean to be an angle bisector? Cuts it in the middle, which means that this guy and this guy are twins. Yeah, I like that word. They're twins. They're twinsies. They are equal to each other. So when we're trying to find the value of x, all we have to do is set them equal, and that's it. So 2x minus 10 equals x plus 15. And then we solve. So I'm going to subtract this x over. So he is gone. And I'm going to add the 10. Can I do that at the same time? 2x minus x is x. And 15 plus 10 is 25. Did I do that okay? Do we have to plug it back in? No. Find the value of x. Done. Okay. Oh, these are my favorite. 3 and 4. Those are my favorite ones. Don't get these wrong because these are like free bonus points, okay? List all of the angles. I'm going to circle the word angles from smallest to largest. Okay, so I have a small one, a medium one, and a large one. Small to large. And I'm going to list the angles, okay? So my angles are going to be H and G and I. And I have to figure out which one is the smallest. So how do I know which one's smallest? I. 1.2 is the smallest side, and so I is going to be opposite him. So I'm going to go angle I is the smallest. What's the medium-sized one? She's writing. H, okay. And then, because H is opposite too, and then angle G would be the biggest. Now, you can just put commas in between them, or I like to a lot of times put like one of these signs in between. Right, like less than. So angle I is less than, angle H is less than angle G. So if you want to do that, that's totally fine. Otherwise, you can just put commas because it just says list them. So you don't necessarily have to put an inequality. So there's that. It does get kind of confusing when you have less thans and then you have your angle symbol. Whatever. Okay, now we're doing segments. So we're doing a little bit different things. Find the shortest segment. So which one is the shortest?
QP.
QP. You are right. 45 is the shortest. So QP. What if you say PQ instead?
Doesn't matter.
That doesn't matter. Okay, QP or PQ. Doesn't matter. Shortest segment. That is all. Not too bad. Not too bad. Okay. All right, BD. BD is this guy right here. He is bisecting this angle. So we got another angle bisector. But then they label this guy here and this guy here. And that's what like our thing is. What?
They're twins.
Are they twins? Are they the same? Yeah, they are the same because they're both at a 90-degree angle, right? Like if by accident, like they made this a 90-degree angle, but then they made this one go this way, like this would obviously be longer than this one, right? But because they're both at a 90-degree angle, this length will be the same as that one. So we can just set them equal. 2x plus 30 equals 3x minus 4. And then we do all our math. I'm going to subtract the 2x and add the 4 at the same time. So 34 equals x. And do I have to plug back in? No. Okay, always check that. All right. Next, write an inequality to compare EF and GH. Okay, EF is this guy and GH is this guy. Okay, this goes back to something called the hinge theorem. And here's what the hinge theorem said. I want my doors matching. I want my door frames matching. Okay, and you're like, what the heck does that even mean? All right, so here's the deal. Here is my door frame. And then my door is swinging open. So here's my door. Okay, so my door frame and my door is swinging open. Okay, on the other end, here's my door frame and my door is swinging open here, right? So I have the same door. Do my door frames match?
Yes.
Yes. Okay, now the purple one is swinging open at an angle of, like, how big is that? 20, right? It's kind of confusing that they label it in the opposite. They should have put the 20 up here, whatever. Anyway, so 20 degrees is how wide he is opening. So my door is swinging open 20 degrees. How far is this guy, the pink one, swinging open? 23 degrees, okay? So now I need to compare this side here to this side here. Which one is, like, bigger?
This one.
Yeah, GH is going to be bigger because 23 means he's swinging open wider, right? He's opening wider at 23 degrees than he is at the other one. So my doors and my frames match, right? Like the 6 and the 6, and then the door is the same, right? But then we can compare the angles on the opposite sides. So as far as EF and GH go, I'm just going to put them in the same order that they are now. EF, GH. You said that GH was bigger. And that's kind of confusing because the 20 is in the way, but that's GH is not the 20. GH is the 23, right? So GH is bigger, so I'm going to do one of these. Okay? Now, if you wrote that reverse, that's totally fine. And you wrote GH is bigger than EF, that's fine. Just as long as we know that GH is the biggest one and EF is the smaller one. That will work. Got it? Make sense? That was the hinge theorem. That's been a hot second. Okay, now we're getting into chapter 7 stuff, which is all like quadrilaterals. So we dealt with like parallelograms and rectangles and rhombus and square, but like the first section of chapter 7 was not quadrilaterals. It's saying like if I have a 16-sided figure, like 16 sides, blah, 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 all the way around, how much do all of those angles add up to be? Okay, and there was a rule for it, okay? So the way that the rule works was that, like, if I section this thing off into a bunch of triangles, each triangle has 180 degrees inside of it, right? But how many triangles does a 16-sided figure have? Do you remember the rule for that?
Divided by something.
No. If I have a 16-sided figure,
16 times 180.
You're close.
360.
no.
I don't know.
There will be n minus 2 triangles inside of him. So how many triangles does a 16-sided figure have?
8.
No. N minus 2. N is 16. He will have 14 triangles.
Oh.
You remember that? 14 times 180. Okay, there are 2 less triangles inside of each figure than the number of sides. Right? Like a rectangle. If I have a rectangle that's 4-sided figure, he will have 2 triangles, right? A 5-sided figure, 1, 2, 3, 4, 5. Oh, that was really bad. A 5-sided figure will have 3 triangles, right? There's always 2 less than the number of sides that it has, okay? And the sum of the measures of the interior angles of a convex 19 or 16 gon. Okay, 14 times 180, that's going to be a huge number.
2520.
2520. So that means if I add up all of these angle measures, whatever they are, right, it would be that many degrees. That's a lot. Yikes. Lots and lots and lots. Okay. All right, one more question before we get into the 4-sided figure stuff. Okay, so we have this guy. All right, how many sides does he have?
1, 2, 3, 4, 5, 6.
He has 6 sides. Okay, so we got to figure out, if I were to add all of these guys up, how much would they add up to be, right? If he's a 6-sided figure, so if n is 6, how many degrees would that be? So, n minus 2 would be 4 times 180, and 4 times 180 is 720, I think. 400 plus 320. Yeah, 720, I'm pretty sure. 720. Okay, now what do we do to solve for x?
We plug it in.
720 is what all of these are going to be added up to be.
Well, we divide by 6.
But they're not all the same. Like this is 7x and this is 4x. So we have like 7x plus 7x, don't write this down, plus 4x plus 4x plus 7x plus 7x. Those are all going to be added up to be 720. All right, let's do some math in our head. 7x and 7x is 14x. 4x and 4x is 8x. 7x and 7x is another 14x. Okay.
8.
What? These two make 28x. And another 8x is 36x. So all together, this stuff all adds up to be 36x equals 720.
Divide.
Perfect. Now divide by 36.
Wait.
That was a lot. X equals 20.
You told us not to write that down.
Okay, you can write that down if you want to, I guess. I was just going to have you skip to the 36x. But if it helps to write that down, you can. You write down whatever you need to. Okay, and we're just solving for x. We're not plugging back in. Okay, good. All right, 9. This is they don't tell you, but this is a parallelogram. I'm going to write that down. Parallelogram. I should have told you that because otherwise we can't do the problem if it's not a parallelogram. All right, if this guy's a parallelogram, I know that this side's the same as that one. I know that this side's the same as this one. I know some other things. They're talking specifically about angles. So like this angle versus this angle versus this angle versus this angle. What are some things that I know
These
are
two the
true?
same, and these-
Yeah, opposite ones are going to be the same as each other. All right, so here's the deal. I know that those two, I know that 3x is going to be equal to y plus 9. Crap. I cannot solve for x and y at the same time. Blue. Okay, so let me look at what I have. I have an x here and I have an x here. Do I know anything about this guy versus this guy if we compare those two? Are they equal to each other? No, like this angle's way bigger than this one, right? Like that's not going to work. But do I know anything about those guys?
Half or something.
No.
I don't know.
How many degrees are in an entire parallelogram? Like what are all four? Yeah, 360, right? So if I take this guy plus this guy,
180.
that would just be 180. These two are going to add up to be 180 because it's like half of it, right? Okay, so I can do that. I can say x plus 8 plus 3x. That has to add up to be 180. Okay, all right. And then I can solve for x there, maybe? Or what are we trying to find? The value of each variable. Okay, so we're solving for x first. Okay, so first things first. What shall we do? If I was in an algebra class right now, you're right. If I was in an algebra class right now, you know what they would do? Minus x minus x. I'm like, no, they're on the same side of the equal sign. What are you doing? Right? So Liv says 4x plus 8 equals 180. Okay. And then let's kick the 8 to the other side.
172.
You are right. 172 divided by 4. X equals 43. Yeah, pretty sure. 43 degrees, or 43. Okay, now I can go back up to this guy right here, right? And I can plug in 43. So 43 is going to go right there. 3 times 43 is equal to y plus 9. And 3 times 43 is 120 plus 9, 129. And then I'm going to minus the 9. So y equals 120. Perfect. That looks like maybe a 6. I don't know. 120. Good? Yeah? There we go. Okay, so parallelograms. That's some stuff that we know about them. All right, let's scoot on down to 10. And this is a parallelogram also. And they tell you that it's a parallelogram. They were at least nice to us. And they say some things. Okay. Let's figure out what this stuff is pointing. Like, what is y plus 3 pointing to? This little guy right here, from there to there. Okay, the 2y minus 11 is pointing to from here to here. The 4x minus 3 is like this little bit, and the 3x is this little bit. Okay, what can I do? This is a parallelogram. What do I know about those little bits and pieces? Those are diagonals, by the way. It's like half, or like chunks of diagonals.
Those two equal each other.
You betcha. This guy equals this guy, and this guy equals this guy. So we're just going to do, are you doing y's first? No, you're doing x's first. 3x equals 4x minus 3. Gross. Boo. Because you're going to end up with a negative. Did you subtract the 4x over?
Yeah.
Minus 4x. But you're going to end up with a negative, which is fine. Negative 1x equals negative 3. Then divide by negative 1. And x is 3. Do we have to plug? We haven't plugged back into any of these. Solve for x and y. Ooh, okay.
So don't change it on.
I know. You just have to be careful. Later on we will. Oh, wait a second. 11. The next one. We're not done yet with number 10, but in the next one, find the measure of BAC. They're going to have you solve for x, and then we have to plug back in. So they're coming. They're coming for us. All right. Y plus 3 equals 2y minus 11. Okay. I'm going to subtract y, and I'm going to add the 11. Is that confusing if I do those at the same time? Or you just do your own thing? She doesn't watch me.
Plus 11.
Yeah.
Minus.
Yep. So x is 3, y is 14. That will work. Yep. Okay, good. Very good. Okay, this is a rectangle. Things we know about the rectangle. They're all 90-degree angles. Also, this length and this length now will be the same. In a parallelogram, not true. This was longer than this one, right? But in a rectangle, the diagonals will be the same. But now we're talking about angles. So let's see what we've got. The measure of DAC. Do you know which angle DAC is? I can see you trace it with your eye. Yep. DAC is this angle right here. This is 2x plus 4. Okay. And the next one is BAC. BAC. This angle. This angle is 3x plus 1. Okay, that's all we know. Are those two angles the same? Can we set them equal to each other? Nope, not necessarily. So what do we do? Is there something that we know? If they're not equal to each other, then that means they have to add up to be equal to something, right? What do they have to add up to be equal to?
36,
No.
20.
This angle plus this angle. Like what's this little corner right here? Yeah, 90. Yep. So 2x plus 4 plus 3x plus 1 equals 90.
Have a drink for you.
Oh my goodness. Well, thank you.
You're still carrying these things around?
Oh my gosh, I'm so ready to be done. Thursday I go back, so maybe it'll be
I hope so.
better.
Fun at all.
I know it. Well, thank you, thank you.
Enjoy, girl.
Yes, thank you. Okay, so now, all right, 2x, 3x, same side of the equal sign, so we've got 5x. 4, 1, same side of the equal sign, so 5x plus 5 equals 90. And then we do some things. Let's,
5x equals 85.
yeah, equals 85. Divide by 5. And x equals 1, 7. Whoop, 17 is what x is. Okay, now, I'll always go back and look. Find the measure of angle BAC. BAC. That was the 3x plus 1 one. Right? BAC, 3x plus 1. So I'm going to take 17 and I'm going to plug it back in there. 3 times 17 plus 1. And that is something. 3 times 17, 51 plus 1, 52. Check that.
Yep.
52 degrees? Awesome. Very good. Very good, very good. Okay. All right, we're moving right along. Okay, okay. Now we have a rhombus. Do you remember what a rhombus was?
R1.
Oh, you're thinking, yeah, you're thinking area. We'll do an area of a rhombus down below, like at the very, very end of this packet. But like, what is a rhombus? Like, what is this? It's a parallelogram. But what's special about him and not just any old parallelogram? Like normally a parallelogram looks like this. Right? So how's he different? What makes him a rhombus?
All of the sides are equal.
Yeah, it's like a tilted square. All of these sides are exactly the same length. Okay, so I'm going to write down here for rhombus. It's a tilted square. If you don't want to write that down, you don't have to. But tilted square, that helps me think. Rhombus is a tilted square. One more thing also, in a rhombus, those things come to a 90-degree angle, right? Like it's like a kite, sideways kind of. And the bars, the center bars, the diagonals going across come to a 90-degree angle in a rhombus. So that's something really fancy. Okay, here we go. It says, oh man, KAL. Which angle is KAL?
The right.
That one. This one right here, right? KAL. And that guy is 2x minus 8. Am I making you dizzy yet? Okay. 2x minus 8. And that's all that we have. We don't have anything else. We don't have like another angle. That's all we have. So what do we know about 2x minus 8?
It's equal to 90.
Yeah, it's equal to 90 because this is a rhombus. So I just say 2x minus 8 equals 90, and we're solving for x. Let's add the 8. 2x equals like 98, and divide by 2. 98 divided by 2 is 49, I believe. Very good, very good. Okay, find x, and that's all we need to find, right? We don't have to plug back in. Okay, 13. What is that thing?
A kite.
That's a kite. Okay, now, things we know about a kite. They already have some of them labeled. Like this side is the same as this one, and this side is the same as this one, right?
These two are going to be the same. I mean, you just
What two are the same?
B and D.
Yeah.
So add
This angle is the same as that one. Yes,
C,
exactly.
A,
Okay. Yeah.
subtract
Yeah. What do they all add up to be? What do all four of these add up to be?
360.
360. Okay, so your strategy, yes, go. What did you say?
70 plus 36.
70 plus 36 is
106.
106.
360 minus 106.
Oh, I don't know why I did that.
254.
Minus 106 is 254. So that means that
Divided by 2.
divide by 2, because they're both the same.
127.
So 127 and 127. That's what those guys are. Yeah, nice job, Liv. So angle D is 127. Same as angle B. Very good, very good. Okay, 14. This is also a kite. Okay, things that we know about a kite. They already have some of them marked. They have that this guy's 12. I don't know if you can see that that's what he's pointing to. This guy's also 12. This guy's 20. Is this guy also 20?
What?
Like this guy's 20 right here. Is this guy also 20? Right here? No. But these two guys left and right are the same, right? Like I'm thinking of the kite being up, right side up. Okay. There's one other really important piece of information that I know for a kite. It's the same with a rhombus, the one right above here. What do I know about those things? The 90-degree angle here as the bar, right? Okay, all right. They want us to find, oh man, they want us to find RH, which is this guy right here. I don't know anything about that. No, they want to know the length here, not the angle. That would be like H, that would be like, they would give us the angle measure.
No, but doesn't the measure just point, the angle just point?
Oh, that's in circles.
Oh.
I'm on your thought, your train here. Yeah, in a circle, like the central angle would be the same as what that is, right? But they want the actual length of what like RH is. What the heck? How do I do that? Got any ideas? This guy right here is a
Oh,
right triangle, which means we can,
A, B, C.
yeah, A squared plus B squared equals C squared. Which side is side C?
The blank one.
The blank one, okay? What do you want A to be?
20.
20? Sure. 20 squared plus 12 squared. I think this might be a fancy right triangle, but we'll find out here in a second. 20 squared is 400 plus 144 equals C squared. And this is 544. Maybe not. Nope, it's not actually. The square root of 544 is something. I don't know what it is.
23.3.
What?
23.
23.3? 23.3. There we go. That's our first decimal that we've had, I think, like all day. Hey, that's crazy. Yep. So he's not a perfect right triangle. Like if you know your triples, right? Like 20 and 12, those will both reduce by like what, 4, right? So if I take 12 and divide by 4, that is 3. And if I take 20 and divide by 4, that is 5. So I have a 3 and a 5. Why is this side not 4? Because isn't that a 3, 4, 5? How come it's not just like 4? That's 3 and that's 5 basically. Like this should be a 3, 4, 5, right? The 3, 4, 5 only works if the 5 is the hypotenuse side. Does that make sense? Yeah, so it's not like this side would have to be 3, this side would have to be 4, this side would have to be my 5 side. So just because one of them's 3 and 5 doesn't mean the other side is necessarily 4. Yeah? Okay, so whatever. So that was not a perfect triple. Okay, 23.3. That is all. Should we stop there?
Yep.
Yeah? Okay, we'll stop there. I'm trying to think of what we have to come next. Okay. All right, we'll do a little bit more tomorrow, and then the following day we'll finish the rest. Holy cow. Man, oh man. All right, there we go.